Hi and welcome to this video on Pharo episode 2. In this video we're going to build a very simple domain-specific language or DSL with Pharo. It's going to be about a dice roll game, which means basically we're going to throw multiple dice all at once and we get to see the result. Now these dice can have 6 faces, 4 faces, 20 faces, whatever you want, but we're just here to have some fun with Pharo and build a DSL overall. So to give you an example of the end goal of this video, we're going to take a look at this expression right here. So this declares a variable, handle, which is like a set of die. And then you have handle, which is going to be assigned a value based on this very specific expression, 3d20 plus 4d6, which basically means that we're going to have 3 dice with 20 faces and 4 dice with 6 faces in it for a total of 7 dice in the die handle. So if we want to inspect that result, we can with command I. And here you can have the attribute dice, which is an array which contains multiple dice at once, some of which are 6 faces and some of which are 20 faces as expressed. And this is the DSL we want to build. That kind of expression is not built in Pharo. We have to construct that. And then you have the roll message, which is basically going to throw all the die in our handle and we're going to get the result. We can try to print it by saying command P and it's going to output 37. It has to be coherent, meaning the total should make sense given the number of faces in the die themselves. More onto that later. But then, as a final message, you have dice number, which is basically going to count how many dice are there in your handle. And of course, it's going to output 7. Before we jump into how to do this, I highly recommend you watch Pharo's MOOC on how messages work, basically. They have 3 types of messages: unary, binary, and keyword messages. It is important that you understand those core concepts before diving into it. I'm going to give you some very brief explanation on how they work, but I highly recommend you check out the appropriate resources for that. We're just going to get into how to build that DSL. So before we do anything, I'd like to give you a clear roadmap of what we are going to conceive, what are the classes, what are the slots or attributes that we're going to have. So here you have a die handle, which is essentially a set of die, as you mentioned earlier. Each die has a number of faces and it has a roll message attached to it. And so die handle has an array of die, which is called dice. It's the plural of die. And as messages, it has add die, which basically pushes a new die into dice. Roll, which is similar to the roll in die, but it's going to roll all dice. And then you have the dice number, which is basically the length of this array. And finally, you have the plus operator, which allows you to combine 2 die handles. For example, you have 3 dice in this handle and 4 dice in this handle. You mash them together, then you get 7 dice, for example. And that's basically what we're going to do for this domain-specific language. A die handle, which is a set of die, and each die has a number of faces, which is by default 6. So without further ado, let's jump straight into coding. Alright, so I assume you know how to create a Pharo image. Maybe you have an image somewhere, you just have to run it. I'm going to use Pharo 13 for this because it's the most recent one at the time of writing, which is absolutely not mandatory. So I'm going to go Command OP as always for the browser, make it a little bigger for you guys to see. I'm going to go in Tile and go full screen mode. So here inside of the browser, we just want to create that new package that we want. So I'm going to do just that. Right click, new package, name it whatever you want, like dice roll game, for example. I'm going to click OK. And what we want to do now is not to write the actual code for those classes. We want to create the test first to be clear about the behavior that we're expecting. So instead of coding, we're just going to go with a new test class. And this test class is going to be called die test because it's going to test the behavior of a single die. We're going to click OK. So the main idea behind TDD is to essentially break things, to fix things, or to make things actually. And the main idea is that it's more satisfying to make a test that did not work instead of just spitting out new features, you know? So we're gonna go with that. So we have not created anything, but we specify the behavior that we want. So we're gonna go test initialize. Test initialize is essentially going to be about the 6-phase die by default. So if I say I have a variable that is called d, and d is going to be equal to a new die, so die class, which we have not created yet, gonna say new. Let me move this a little bit upward, that way. So die new message to instantiate that. And then what we want to assume is that as we assert that on that die, which is called d, we're gonna retrieve the number of faces, and it should be equals to 6, right? So if I try to save, it's gonna complain that die does not exist. We're gonna define a new class, and we're gonna say okay. That's one of the things I like with Pharo. The debugger is really intuitive. So I'm gonna click on die. So already we have the die test right here for the constructor. Of course, this message does not exist, but we're gonna see that later on. So here I want to create the slot for the faces, right? And I'm gonna save. And right now I want to generate the accessor, the getter, and the setter. I would do it by hand normally, but I'm gonna go with the shortcut this time. I'm gonna go Command GA, and it's gonna generate all of those getters and setters. We have faces as a getter, faces with the comma, I don't know what's it called in English anyways, which gonna set the faces, okay? And now what I want to do is I want the initialize method. And initialize method is basically the equivalent of constructors in any other languages. So what I want to do when I initialize is that self.faces, I want to, or maybe just faces actually. So I want faces to be 6, and that's it. And let's see if it works. So yeah, it works. So just to remember how it works, this is what we just have specified as a test, that by default, unless we specify otherwise, that means the die is going to have 6 faces. So that's one good thing done. Moving on to the next. The next feature is going to be the role message. And for that, we're going to create our test. And so we're going to say test role. And test role basically is pretty much the same. Like we want to have some set of die, and D is going to be die new. And then once it's done, I want to assume that it does not output anything awkward. Okay, so what we want to do is I want to assert that the result of D when I roll it, and I'm going to put parentheses here for good measure, when I roll it, it should be between 1 and 6. Why? Because by default we have 6 faced dies by default, okay? So I'm gonna save that and hope that I did not make any typos. So I'm gonna save that. Yeah, we made some mistake here. So right here, it is a good example of understanding how messages work in Pharo, because there's a priority you need to learn. So let me try to fix this by moving up the parentheses. So I can move the parentheses up here and I can save. Now it works, but it's gonna complain that role does not exist. Anyway, we can try to run it, and we should. So we're gonna break, and of course it's not gonna work. Role does not exist. So we're gonna create that inside of the die class, and right into the debugger, we're gonna code right here. So here what we want to do is generate a number between the number of faces and 1. So we're gonna output some random number. So what we want to do here is we want to return the number of faces at random. And that's basically it. So at random is a message you send to an integer. It's going to return a random number from 1 to that number which we are referring, which is the number of faces. Right now we can try to proceed and we see that it works, but it's not quite like enough, I would say. Maybe we got lucky, okay? Maybe we got lucky, and then what we want to do is repeat that enough times to be convinced that it works. So for example, I like 10,000 times. I want to go times repeat, and then we need a block, which is essentially the same as lambda expressions in other languages. So I'm going to do that, and so I'm going to add back the self right here. Self, okay. So here we have the same test. We want to assert that every time I roll the die, a 6-face die, the result is always going to be between 1 and 6 inclusive. And we're going to repeat that 10,000 times just to be sure. So if you try to test it, it works. That's the beauty of test-driven development. You write the test and everything goes according to plan afterwards. So here we tested initialize, we tested roll. I think that's basically it for the die class. So now we're going to create the die handle class, which is an array of dies. And then we're going to have these methods that we want to implement. So let's do this. So here I'm going to get inspiration from this die class right here. And I'm going to say die handle. And instead of having faces, it's going to have dice. And I'm going to save it. Then I have my class. Of course, I need to write the test first because that's good practice. I'm going to write the test first. To specify the behavior, I'm going to create new test class. And this test class is going to be die handle test. And I'm going to say OK. And now the die handle test is here. Instance side method to write the test. What do you want to test with that die handle actually? So by default, you want to test a few things. For example, test add die is okay, for example. So what this essentially does is that we verify that the die has been inserted correctly. So if you have like a variable h, and with that h, we're gonna assign it and we're gonna say die handle new, and to the created object, we're gonna send a few more messages actually. We want to say add die, like for example, I don't know, add die, and I want to add this die right here, die new, and I want to keep sending messages to that same instance. Like I want to send other messages to this particular object, so I'm gonna do it. Add die again. So I'm going to add die new, and then finally, since we're trying to assign something to this h variable, we need to make sure that the return object of the last expression is the die handle itself. Let me explain. In certain languages, for example, add die might return void. Add die might return a boolean saying that yeah, it has been added successfully or not. And we don't want to affect that boolean to h. So what we want to say here is use a keyword called yourself. Yourself essentially means that it's going to be the object where we're sending messages that is going to be affected to h. We don't want the return value of add die to be assigned to this, do we? So with that said, what we want to assert is that serve assert, and we want to say h dice number is equals to 2. That's basically it. I'm gonna save, and of course it's not gonna work, so we have to debug it now. We're gonna say run, and we're gonna create that method. We're gonna add a die, then we want to say dice add a die, and if you try to run the test once more, a few things still are not working. So add is not working because dice is null. Remember, we have not defined that yet. So if you look at die handle, it's not registered in yet. So here what we want to do is generate the accessors, right? So I'm gonna go Command GA, generate all of these niceties, and then you have dice, But then again, what is the type of dice? That's the thing with Pharo. It's like it's a dynamic type language. You have to set the type first. And where do you do that? Of course, it's in the initialize method. And initialize, what you want to do is set the dice to something like an empty array. And an empty array is going to be either ordered collection if you want to preserve order, or unordered collection if you don't care about the order of insertion. I'm gonna go with ordered collection just because I feel like it. New, there we go. So now we have a dice which is an empty array, an empty ordered collection, right? And then we have a die method which should work properly, unless, of course, again, I've been clumsy and this is not the right method, again. So let's look back at our test, right? There's this thing that does not work. If you try to do the test, dice number is not built. So I have to create that, right? So we have to create dice number. So we're going to return dice size, and that's it. And now we can proceed, and we see that all the test now works. It's satisfying to solve that problem that the test now works as it should. Keep in mind that the yourself keyword and the way message have been handled in Pharo is really largely covered in the Pharo's MOOCs, which I highly recommend. Like, I can't recommend those enough. But for those of you who are just here for the fun stuff that we can do with Pharo, this is just how we work with Pharo. And I think it's a great example of applying TDD or just coding in general. We'll talk more about design patterns later. And so the next one, if I remember correctly, is going to be the roll method, which is basically you roll every single die in the die handle, right? So here what we want to do is we want to create the test for it, of course. So here what we want to do is I'm essentially going to copy the roll test from the die test that we had. Remember this one? We have a die, roll it, and the number is expected to be between 1 and the number of faces, like 6. We're just going to do that, but with multiple dice this time. So here we go. So what we want to do is we're going to create a new method, and this time around we're going to say test roll, and we're going to write some test. I'm going to say h, and h going to be assigned to a die handle new. And to that new die handle, we can start to add a few dies. We're gonna keep it simple. We're just gonna use 6-face dies, but we can create a static method to create dies much more easily. So, since it's easier to create dies with 6 faces by default, we're gonna go with that just to simplify the test. So here what we want to do is we want to add a die, and that die is going to be a die new. We're going to say another one, die new, and then finally maybe one last time we want to add a third one to the handle. And finally we're going to say yourself because we want to assign the actual object to h, right? So yeah, here we go. We have 3 dices, we have 3 dies. The maximum result you can have is like 6, 6, 6, and 6 times 3 is 18, I guess. Yeah. So what we want to assert here for 1,000 times or 1,000,000 times, no matter. So I'm going to go with 10k as usual. Times repeat. We're gonna go into a block or a closure. So here inside of the block, I want to specify that I want to repeat this expression right here. I want to assert that the h handle, when we roll it, it is always between 3 and 18, right? And finally, I'm gonna add the dot at the end. That's it. And of course, some of these does not work because the test is not ready yet. We still have the roll method, so I'm gonna run it, break it, create it, as always. And so the roll is going to be implemented here. This is going to be a very basic accumulator thing when we can have something like sum, and then you're gonna say something like sum equals to 0. It's very classical in algorithm classes. And then what you want to do is you want to loop over each die inside of dice. So dice is the array, and what we want to do is call a loop with do. And then we're gonna have a block. So here I have to give a name for every single element inside of dice. I'm gonna call them die. I'm gonna go vertical bar. And each die, what I want to do is I want to do something like sum equals sum plus die row. So I want to make sure that I have the result of row added. It's just a basic sum with arrays and loops. So now we have a sum. We must not forget to return it. We're gonna return the sum, and that's basically it. It's pretty elegant, isn't it? So that's sum in a nutshell. We're gonna go and see if it works. Did not understand assert between and. Maybe I have the wrong parenthesis going on here. What we want to have is this, maybe like that. I call it maybe because that's the impression I got when I first did these things. And we're gonna run it, so now it works. So for 1,000 times, 10,000s of times, we rolled each die and the result was always between 3 and 18. I don't think there's any need for a higher number at this point. So that works. Let us arrange a few things, okay? I think that to create a die with faces other than 6, we would have to do stuff like this, right? So for example, you have your die and you're gonna say that it's a new die, but then you have to say like faces, you have to call the setter and you have to say 20 here. I think this is a bit too long. We're gonna create a method, a class method, to build die in a much more shorter way, so to speak. So I'm going to erase this and I'm going to click on this little button here. I'm going to switch to the class side, which is usually described as static in other languages. So I'm going to go inside of die, and here, class side method, I'm going to create one. So we can call it whatever we want, but I'm going to call it with faces, and as a parameter, we're going to have an integer, right? And what this is going to do is that it's going to return a die new, and then for that new, I'm going to say faces equals to that integer, right? So that's basically it. And to make sure that I return the correct stuff, it's not necessary at this point, but I just want to make sure that it returns what I want it to return. So I'm just gonna say yourself. It's not necessary at all, but just to be sure. So there it is. I have to test that actually. I can't believe it works or not. So now what we want to do, we want to test that. So I'm gonna go instance side method, die test, and then let's test that thing. Remember, it's on the class side, right? What we want to do, we want to have some variable called d, and d is going to be assigned to the class die, and since die is a class, we can automatically call its static method without creating an object. So we can say with faces, and I'm going to say 20, and then we're going to do our assertions. So self assert, and what we want to assert is something very simple, that d faces equals 20. That's basically it. Let's test that. So actually, it does not work. Did not understand equals. Oh yeah, wrong parenthesis again. I'm doing this to showcase most of the common mistakes that I see with beginners, and I think I made them as well when I first started, but it's all part of the process, right? So now it works. So now we have a much more elegant way to create die with different faces. So now we're done with the logic, right? Now we're done with the logic. Essentially what we want to do is we want to be able to say some kind of variable is going to be a die handle. And inside of that die handle, we have like 2 dies of 6 faces plus maybe 3 dies of 10 faces plus 1 die of 20 faces maybe. So here we have 6 dies inside of a handle, and that is the small DSL that we want to implement. So if you watch closely, this is a message and this is an object which receives the message. So in a way it's like that, okay? So what we want to do is that for each integer or small int, there is a message called d something that exists. And so we're going to touch to the kernel or the core of Pharo to add that as extensions. We can do that, don't worry. So this is what I like about Pharo. We're allowed to touch into its core without affecting everyone's experience with it. We can break Pharo, it's okay. They all have images anyways. So let's now start with D20, okay? So we're going to start with D20 as an example. So what we want to do is that we want to specify the tests first, okay? So let's test things like test simple handle. We want to specify with the DSL something. Does it really register it the way it should? So now what we're going to do is going to have h, and h is going to be assigned to a certain expression with that DSL. Let's start with something very, very simple. We're going to say 7 dies with 20 faces, okay? So here we have that. Next, we're going to assert that. Next, we're going to assert that if we look inside of h, like so, h dice number equals to 7. It has 7 dies. The second assertion that we could make, which is totally optional, we can verify that each die has really 20 faces. So we can say h dice do, and then create a block, and each element vertical bar, we're gonna say for each element we're going to say self assert, and we're gonna assert that each element, if you grab their faces, it's gonna go equals to 20 all the time. So I think that's a good test to live by. So of course we break things to make things, save. And of course there's an error right here, because if you try to run it, the message d20 does not exist for integers, right? So small integer did not understand d20, so we're going to create that. And so right here we will inside the kernel package inside of the class small integer, and we are writing the message d20. So d20, what is it? So what it's going to do is essentially it's going to create multiple 20 face dies and put them in a handle. So what we want to do is maybe we want to create a variable first, like the handle here, and h is going to be die handle new. You can optimize this to your liking. And then right now what we want to do is that we want to get the value of self, because the self is, it designs a small integer. And now we want to say times repeat because we want to repeat something. What we want to repeat on h is that we want to add a die that has 20 faces, right? So die with faces 20. So here we have a die handle, which is h. Don't forget to return it as a result. So we're going to return h as a result. So essentially what we did, we create a die handle and we repeat a certain number of times depending on the small integer we're sending the message to. And then what we do, we add 20 face dies that many times. Okay, so I'm gonna save that and hope everything works now. As you can see, it now works. What does work? We can specify die handles using that type of expression now. And if you look here at the kernel package, which has all of the kernel of Pharo, you have numbers, and then you have the small integer. You can actually see the code we did in the debugger. Where is it? Where is it? There it is. There it is, D20. And so we can create the same type of logic for D20, D10, D6 as much as you want. We could try to copy paste the code, but at this point, what I would recommend is like coming up with a generic method to be reused by all of them. So what we want to do, let me just specify what we want to do. How do you do that? Tests, of course. So here, die handle test. I'm gonna write the test first and then we'll move on. So what I want to test right now is I want to test the addition. So it's gonna go all at once, like test addition, like test sum of two die handles. So basically what we want is like you have a certain handle and then the handle is going to be 2d6 plus 3 d20. Okay, and now what we want to specify is that maybe we just can say self assert. What we want to assert is that h has like 5 dies at this point, equals message, don't forget that. And yeah, I think that's basically it. It should work actually. Remember, this returns a die handle, this returns a die handle. The only thing that we have is that D20 has been written, D6 has not been written. So if we save and test, we're gonna create a certain method. But honestly, I think at this point, we're going to have to resort to a much more better approach. So I'm going to say shift enter, and then I'm going to retrieve the small integer class directly. It allows me to scan through all of my classes. So small integer, there it is. So small integer, there's something I want to do. Here, there is something I want to do. Instead of implementing the same logic every time, I'm talking about this logic actually. I want to be able to have a generic method. So what we want to do is something like this. D sum integer is going to be used by all of them. So what it is going to do is going to create a certain handle, and inside of that handle you're going to say die handle new if you really want to do it, and then for the number of times like self times repeat, what we want to do is h add die, and then you want to have die with faces, sorry about that, faces, and then the integer that is passed on as a parameter. So here let me pause for a second because I think like it's way down here. So here we have a generic method that can be used by the others. That's the sole point, because we don't want to repeat the same logic, copy paste this everywhere, because it's common to all D20, D10, D6. So we're gonna save that and we're gonna use it. So right now what I want to do is use this, okay? So instead of just writing it down in D20, I can simply say, actually what you meant to say is going to return self D20 like that. That's it. That's it. So did I save? Oh, I'm not sure I saved actually. Actually, I forgot to save this. So I'm gonna save it. So now it is saved. Everybody's happy. I want to show you guys the code again. And D6 is basically the same thing, right? D6 is basically calling the same method, but using a different parameter like self D6. And you can do that for D10 or D20. We can actually do D10, I think, right? So D10, you have to return a little something like self D10. That's it. So we have that. And now we can go back to the test. To navigate back to my old code, I'm just first going to close this. So right now, this should work, except that the plus message does not work. What we want to do is, again, run the test and see if it works. Oh, sorry, my bad. I think I forgot something. I forgot to return and then small integer. It's a little bit funky sometimes. So if we go back here, we can see that I made a mistake. I forgot to return h here. It happens. So I forgot to return that, and that's basically good. So here we want to run all the tests back. So everything works except one. If we try to run it, The one thing that we don't have now is that the plus message is not being understood. So we're going to create that. Where do we want to create that? We want to create that inside of the die handle. So yes, we can override what plus means inside of each class. So it's basically pretty simple. It's going to merge both die handle, the self and the other. So the result is going to be inside of a variable called h. And for h, it's going to be initialized as a die handle, right? And ultimately what we want to do is that you want to stuff the die from the first one and then stuff all the dies from the second one. Basically simple. So here, what we want to do is that we want to stuff the first one like self, dice, and we want to do a certain amount of things. I can go with each because it's much more practical. And for each die inside of the self, what we want to do is h add die each. You can call it whatever you want, but each is what I called it. I think die is a better name overall because it's like the singular one of dice. And actually we want to do the same thing again, but this time around we want to do it for the other die handle. So we're going to say a die handle instead of the self. Yeah. So here we added both, and unlike earlier, I'm not going to forget to return h, right? So here we have it. Gonna save, and then gonna proceed. Everything works. So right now, what do we have? We have a DSL that allows us to specify a die handle. We can sum them, we can roll them, and now we have the end result. So I'm going to close all of it and see what we got now. So what we got now, if we open the playground, we can basically say anything like h, like any handle, like my handle, and then my handle is going to be 3d10 plus 5d20. You can actually see that when you inspect that, you have 8 dies, like from the first one to the 8th one, right? And if you see here, the 8th one has 20, the 3rd one has 10, basically the same thing that we specified down here. And of course, we can roll that handle if you want to. You can print it 52, which makes sense if you do the math. So yeah, in summary, that's basically what I have for this game. So yeah, that's basically it for this video. I hope you enjoyed it and that you learned something fun. There's much more we can do. I like the fact that this simple practice outputs the DSL first, and second of all, it encourages test-driven development a lot. So I hope you have learned from the mistakes in the video, you have learned from the good parts of the video. I'll see you guys in episode 3. See you around.